讲述的过程当中，我们会改成全程用英文分享。那就是说，就是其实今天就非常开心，可以难得让大家一起互相学习啦。那如果大家等等有任何想要发问的部分啊，也可以欢迎就是说在我们的留言区这边留言，那或是说就是或者说事后也可以就是欢迎就是可以把一些问题也透过 email 或是等等方式也可以分享给我们这样子。好，OK，welcome everyone. It's very glad to see everyone here. Yeah, today is a green energy workshop. So I think it is very happy to see everyone and not just from Taiwan, but for other countries like Malaysia, Singapore, Indonesia, Philippines, or the other countries. So, okay, let's get started. Yeah, okay, so today is a workshop about the green energy. And because today we have many country uh, partner here, so I think this is a very great opportunity to share the experience or share some ideas each other. Okay, and we can learn each other too. So why we need to learn green energy? Yeah, I think we all know that the green energy is become more and more important today. So why we need green energy and how the green energy work and what the green energy look like in the future, I think is very important. So this is the today's topic we will follow. So what is green energy? Yeah, I think lots of teachers have already know this, but I think today we have some students here, so we just start from the basic concept. So the green energy is typically a renewable and environmentally friendly and sustainable source of energy. So the green energy have the following characteristics, like replenished and very low or even zero pollution and smaller environmental impact. So this is the common type of the green energy, like wind power or photovoltaics or hydropower, hydrogen, bioenergy, ocean, geothermal, or solar thermal, or the others. So the next we will focus on the development of the green energy in Taiwan. So yeah, this is the figure. This is the figure from our government. So we can see the information. So we can see that the green energy, and we also call the renewable energy, become more and more. Become more and more. So in today's, we will focus on the green energy in the future. So we can see this is another figure about the each green energy. So a different color represents the different green energy. Like the orange color is photovoltaics, and blue color is wind power. And we can divide the wind power to onshore or offshore wind power. So we can see in Taiwan, the photovoltaics and the offshore wind power become more and more. Yeah, so in Taiwan, we will focus on the offshore wind power and photovoltaics. Yeah, it is the main green energy in today's. So why Taiwan is suitable for developing the wind power? Yeah, we can see this bar chart. Yeah, we can see this bar chart for the different months of the electricity. It is October and this is January. We can see in the winter, the more energy from the one convert to the electricity. So I think lots of teachers already know the answer. Yeah, because the main reason is the northeast monsoon. We also Chinese call 东北季风. Yeah, because in the winter we just attacked from a strong wind. So I think it's also bring a lot of energy. So it can trigger the wind turbine. So I think this is the main reason why in the winter, so more wind can convert to the electricity. And the other question is why Taiwan is suitable for developing the solar power. Yeah, we can also see this bar chart. And we can see this is July and this is October. So we can see in contrast to the wind power, in the solar power, we can see in the summer, more energy from the sun will convert to the electricity. So I think the reason is very easy because in summer, the sunlight will direct to the northern hemisphere, so we can see it's more sometime in the summer, so it's more energy we can get from in the summer. So that's why in the summer more energy from the sun can convert to the electricity. Yeah, so this information we also get from our government. So what will the green energy look like in Taiwan's future? So yeah, we can see this is our government policies vision. Yeah, so we can see by 2030 we want to our government want to increase the green energy percentage to 30%. And by 2050, our goal is toward to the net zero. So I think this is a big dream. So our government have a very work to do. So yeah, so our government continue to promote the energy transition in three main direction. For one is solar power, and the other one is wind power and energy storage system like the hydrogen. So the key technological developments on Taiwan is for offshore wind power, solar cell, or hydrogen fuel cell. We also called PEMFC or smart grid. But actually, we also face some challenges like the limited land resource or the grid integration and stability and the cost and the public acceptance. Yeah, but I think our government wants to want working hard and produce. They want to uh, achieve our target. Yeah, so our government in Taiwan we need to work very hard now. So why it is important to develop the green energy education? Yeah, I think the main reason is why because this can raise the environmental awareness and cultivate future talent and drive social transition and enhance hands-on and innovation skills. So how do we do? How do we develop the green energy education? I think we need some good uh, equipments. So this is the leXsolar renewable energy experiment set. Like the left one is hydrogen, and the middle one is PV. We also call photovoltaics or solar power. Or the right one is wind power. So this is our the renewable energy experiment set from leXsolar, and these are modular design and allows for quantitative and qualitative experiments. And it also includes the sample lesson and experiments. So the next, we will invite the leXsolar product engineer, and he will show very good and very great the experiment on this experiment set. So the next, just let us welcome Ronald, that he will get very great the demonstration of this experiment. Okay, so we can welcome him.
Hi, John. Yeah, nice to meet you all. My name is Ronald Hübner. I'm a product developer here at leXsolar in Dresden, Germany. And yeah, today I'm gonna demonstrate to you some of our products. I believe, John, you have another slide where we can see all our products at first. So you see here our little overview. So we cover every side of renewable energy. Yeah, we have PV products. We have a product on wind, on biofuels, on e-mobility, on hydrogen, on wind technology, and on smart grid technology. Yes, and water too. So of course we only have an hour here for demonstration, and I believe for today we start or we focus on the hydrogen energy at first, and then I will show you the wind and the PV products. Please note we have products for school and for university. The school products are called leXsolar ready-to-go products, and the university products are the professional products, which focus more on the quantitative side of the experiments, and the ready-to-go products, the school products, focus more on the qualitative side, on the phenomenological side of the experiments. So yes, John, can you close the presentation, please? I will switch cameras and we will see how our products look alike. Oh. Okay, camera is not working, please. Give me a second. I don't know why I can't use the camera. Am I online?
Yeah.
Okay. Fuck. Oh, now we have a camera. Oh. Okay. So here I am on my demonstrating spot. So let me show you our products. Let's start with the H2 products. So our leXsolar equipment comes in these cases where everything is included within the ready-to-go products that you need to experiment. So let me open it. These are our experimentation kits. Generally speaking, every kit has like the same design. Yeah, you have a little overview card with a code. With this code down the corner, you can download the free manuals we provide in English, of course. And if you want the translation into another language, we also can manage this. But basic is English. So this is the H2 ready-to-go experimental kit. With this kit, we want to demonstrate different types of fuel cells. And this is what I will gonna do now for our little presentation. I have with me here to compare the experimentation kits. I have here the H2 professional product. The professional product you see is a blue case. Looks a bit different. In here, we only have one fuel cell, one bigger fuel cell. So show you the difference between professional and ready to go. This is one fuel cell in the ready to go. It's a PEM fuel cell with a polyelectrolyte membrane, and in here we have another with the professional fuel cell. We have a bigger fuel cell for only fuel cell experiments. We can do with the professional experimentation kit. We do only experiments on the polyelectrolyte membrane fuel cell, and within the ready to go, I have a normal, a little fuel cell with a polyelectrolyte membrane. I have an ethanol fuel cell, and I have also an solid oxide fuel cell. I will demonstrate now the ready to go product, and if we have time at the end, or if you have questions, I can also demonstrate the professional products, but for today we go with ready to go. So let me demonstrate our experimentation kits. Every experimentation kit has this ground unit, base unit, where all modules can be put on here, just plug and play. This is one of the modules, and you can just plug it onto the base plate. And this is how we generally opt for our experiment. The student gets a little drawing within the manual, and then can pick out the modules and can set up the experiment. And for today, I will do it very quick so you can see our equipment is working. I will connect two polyelectrolytic membrane fuel cells in a series connection, and with that will run my little propeller here. Again, the ready-to-go product is focused on phenomenological experiments, meaning that we try around with the fuel cells with the parallel connection. It's also possible to install a series connection and a parallel connection, and to investigate the differences between. We have some measuring devices within the experimentation kit. These digital multimeters. And with that, we can measure current and voltage and calculate the power. And from quantitative side, that's it within the ready-to-go set. With the professional set, we can do some more experiments on this side, but now let's focus on the fuel cells. I have a little storage, a little H2 storage device here. So what have I done here? I will show it again to the camera. So here we have two fuel cells in a series connection. I will add some hydrogen. And the motor will spin. First up. So I added some hydrogen and the motor will spin. So this is phenomenological experiment. And now, we demonstrated how a fuel cell works, of course. And now we go and can check the power, the voltage and the current. So we use a potentiometer regulating resistance in between, and can regulate the resistance, get a UI chart, and calculate the power and the maximum power point. So this is quick and dirty experiment now, which I set up for today, demonstrating how fuel cell works, how a classic fuel cell works. Another thing I want to demonstrate to you is now we take another fuel cell and compare how the fuel cells work. You see, for the polyelectrolytic membrane, I obviously need hydrogen. Hydrogen is also created within my experimentation kit with an electrolyzer. So I have an electrolyzer here. I need distilled water. I also put my electrolyzer here onto the base plate. I can interconnect the modules, and I need some distilled water, and I can split the water into oxygen and hydrogen, and I can also take this hydrogen generated here for powering my fuel cells. So this is another experiment, and now I can compare the fuel cell with the hydrogen to a solid oxide fuel cell, SOFC, which I have here. I hope the camera will get it. So the little ceramic tube in here is a solid oxide fuel cell, and when heated up, it generates a voltage. So I will set it up to demonstrate to you how that it works. Again with my little propeller here. So interconnect everything. Yeah, and again, to do so, we have a manual. Generally, everything is explained in this manual. I have a little burner also included within the set. Now it's burning, and if I'm heating up the fuel cell a bit, in a few seconds, it should start to spin. So let's see. Or maybe I can hold it up a bit and you see it's glimmering already. It's heating up. Complicated in the street. And now if we close the electrical circuit, of course, the motor is spinning. So solid oxide fuel cell heats up, and yeah, the oxygen goes through the ceramic. The oxygen gets split, not the hydrogen here. And we have electricity, voltage generated. So this needs to cool down now. So you see different types of fuel cells shown phenomenological. Also, we have this ethanol fuel cell, and the next experiment, of course, is working out the ethanol fuel cell. So we need 20% alcohol to run the experiment. Also for demonstration. I have some ethanol with me, and I will hold it to the camera. So let's take some time to start. This is the next experiment. It's an ethanol fuel cell. Oh, come on. spinning. Okay, so now propeller spinning, ethanol fuel cell also is running, it's working. And this is my demonstration at first onto the different types of fuel cells. 3 different types: ethanol fuel cell, PEM fuel cell, and SOFC fuel cell. Everything works. Now we also have an electrolyzer in here. And what we also have, I want to show you, is this module, the H2 charger, which charges our storage module. In here is like 10 liters of hydrogen stored, so you don't need every time to produce hydrogen with the electrolyzer. Can use these ones here for quick experiments like I showed you. Okay, and we're also providing this, obviously. So to compare this now, I show you the Pro variant of the experimentation kit. Also, yeah, just notice. Also, we have a PV module in here, so you can generate green hydrogen with the electrolyzer and this solar module, which is also a great experiment. Yeah, to show that this is possible and it works perfect. So, next up, just to see the difference between Pro and ready to go, I have here the Pro variant. I won't do an experiment now. I just want to show you the difference between the 2 experimentation kits. So now we only have one fuel cell, one bigger fuel cell, which is capable, which just has more power. You can do better, decent experiments on power, calculating power, voltage, and current. We also have a bigger electrolyzer here. It's capable of holding up to 80 milliliters of hydrogen. We again have these storage modules. We have a car model here. The car model works with the fuel cell, so you can run the car with the fuel cell. And we also have a big solar cell in here to generate green hydrogen with the electrolyzer again. So main difference here is this bigger fuel cell, which can be taken apart, can be examined partly, can be put together again by the students, and this also needs a bit more maintenance, like a real fuel cell, if you want. So you have to check the pressure of inside the fuel cell, that there's no H2 leakage. You have to do some maintenance. Yeah, this fuel cell needs to be used or flushed at least once every 2 months, so that it works properly. And yeah, we also have again a potentiometer in here and some measurement devices. And we do an experiment on the current versus the H2 usage of the fuel cell. And yes, also we have an experiment onto the oxygen usage of a fuel cell in here. So yeah, we focus totally on PEM fuel cell within the professional kit, and in the ready to go kit we have the demonstrating 3 H2 technologies yeah, for comparison. So this was the first part of the demonstration for today. And I will continue with the wind. If there are any questions, if you want to see another experiment, please ask me at the end. I can also show, of course, other products of our company. But for now, let's continue with the wind. For wind, I have here the Wind Ready to Go product. Again, Ready to Go is a school product. We focus on phenomenological experience. Wind. What is said about wind? Again, this is the experimentation kit. We have an overview here, and overview chart here. We can download a manual for our experimentation kit. So, how does wind works? At first, yeah, let's see. Here are all the components of our experimental kit. We again have this base plate where every module will be placed on. We have digital multimeters in here to calculate voltage and current. Also, please note, generally we are working with 4mm plugs with our cables. So every cables with 4mm plug works with our experimentation kit. So if you have a laboratory, a physics laboratory, a technical laboratory or something, works also with our experimental kits. Yeah, if you have digital multimeters at school, use them, no problem. Okay, let's build up a small wind experiment. Again, we use the base plate. We use the base plate. We have a wind machine with the experimental kit, which is creating a laminar airflow onto the wind turbine. I will, or I can, put together different kinds of turbines. I will demonstrate to you the difference between two of the turbines. I can put them together. I will show you two different turbines, one with 3 rotor blades and one with 4 rotor blades. Oops. And this is how we again do our experiments. We can combine them very quickly, put them up, and show the students how the technology works. So this is my turbine, classical, with 3 rotor blades with this classical triangle shape, and I will compare it to the windmill type of a rotor blade, and I have again a rotor with me, which is spinning if I'm doing everything right. So now we need some electricity, of course. We have not only these yellow modules, we also have the blue modules, which are regulating modules. We are working with 0 to 12 volts with all our experiments. So it is safe for the students. Nothing can happen. And I will now put on the wind machine. And by regulating the incoming voltage, the wind machine obviously will spin faster or slower, so I can adjust the wind speed by the input voltage of the wind machine. Now it gets a bit loud. And you see it's spinning. And so this was demonstration that it works, and now I will put on the other rotor blade and I will start again. And now, so this is obviously proof that our experiments work. And now what I want to do is calculating the power, the voltage and the current, which is generated by the different rotor blades. So I will add up at first here. I will measure the voltage, and then I will measure the current, and obviously the older windmill will generate less current, less voltage than the triangle shaped one. So what I can do further is I put it apart a bit, running out of time. And what I can do now, let me demonstrate it out. So as you have seen, I have changed the number of the blades. I can change the number of the blades. I can change the generally form of the blades. I can change the angle, the pitch angle of the blades into the wind. And I can obviously, by turning the turbine in a different angle, I can also demonstrate if the wind's not coming directly in front of the turbine when it's coming from this side. So I have different parameters that I can alter. And the way it works is we always alter one parameter, calculate power, measure voltage and current, calculate the power with the potentiometer module again, and this is how we can opt into with which combination of blades, of number of blades, of angles is the best for a wind turbine. And also to investigate the difference in, or to demonstrate the difference in the axis of the wind. We have a Savonius rotor within here, which has different in a 90 degrees changed axis where the wind blows into the rotor. Yeah, here we have a horizontal axis, and here we have a vertical axis, and this is also to demonstrate the difference in different wind technologies. So again, this was my small demonstration on wind technologies. Also, if you have questions or if I should demonstrate something again at the end, no problem. So again, I will pack everything back into the experimental kit and show you now the last product for today, which is photovoltaics. So photovoltaics, again, to show you, I have a ready-to-go product with me and a professional product with me. And here you see again big difference in professional, so university product and school product. With the school product, again, we focus on phenomenological side, and with the professional product, we focus on calculating side, especially on electrical side. Again, we have our experimentation kits, which always look alike. For every experimentation kit, we have a manual provided for you in English. And you see here a big difference between professional kit and the ready-to-go kit. For the ready-to-go kit, we focus purely on PV technology. What is a solar cell? What is a solar module? How can we interconnect them? How does that work? And within the professional kit, we provide some regulating modules like a shunt regulator, like a pulse width modulating regulator, to really focus on the maximum power point and onto set up a real PV photovoltaics power plant with the regulator you need and with the energy storage also you need. So for now, for demonstration for today, I have the PV ready to go. So again, ready to go product means everything you need is included for experimenting. Now let me demonstrate a little experiment. I will so at first you see we have again the base plate where everything is connected. At first things I want to show you is that we have, see how the light is. We have these small solar cells. This is a single solar cell. We have different sizes of solar cell. We have a bigger one with a big surface, obviously, to do experiments with the surface area. And we have another module where 3 cells were in a series connection. And this is the first thing we want to show the students. They need to have the solar cell in hand. They can check it. They can see the conduction lines on top. We can explain them what is the PV junction, how does it work, and then we can demonstrate that the solar cell itself works. So I will take my solar module again. And my motor module again to demonstrate to you that it also works. So now in my office, obviously, no sun is shining. And for this case, we have a special designed lamp with us, which I will show you. Again, we have a power module, and the more power from 0 to 12 volts we give our lightning module, the brighter our sun is shining. So again, here we can investigate different levels of radiation to the solar cell or solar module gives us different power. We can calculate that power. We can interconnect a potentiometer. So we have a regulating resistance for the PV charge to get the maximum power point out of the solar module or solar cell, whichever you like. And for now, I will demonstrate to you a little experiment here. This is a lamp. And as I turn up the power, the light shines brighter. And the motor module is running. Which I also, what I also can do is measure the heat of the solar cell with a thermometer here. So I can see that if the solar module heats up, the power goes down. Can explain why this is happening. And yeah, this is a phenomenological experiment that our kit works. And now what I'm doing is I will take my 3 solar cells and I can interconnect them in a series and in a parallel connection and can investigate what is the difference between series and parallel connected solar cells. How does it work? Obviously, I have no light again here. Oh, if this is enough, I don't think so. So this is an outside experiment in generally. PV experiments are best suited for outside experiments when you have the sun for you. Exactly. Now we can use a diode within our connection. Yeah, if I take one of the solar cells out, I can add a channel with a diode, simple as this, plug and play. I can use a horn module for an acoustic signal for the students. And also we have a little motor in here with a weight to calculate the force I can generate within the electricity of the solar cells. Okay, so this was quick presentation of 3 of our products. And so if you have some questions now, John is ready for you. I am ready for you. Have I forgotten something, John, or have you gotten everything? I was very fast, I know, but there were a lot of products. So I hope you could get it. Here I am again.
好，那我们非常谢谢 Ronald 给我们带来非常精彩的一个实验的一个演示后，It's very thank for Ronald for us for a great demo and let us know about 3 different kind of the green energy, how to work and how they can help students understand the energy transition about the hydrogen and solar cell and the wind power. So, is someone else have some question want to ask? Don't be shy, or you can we can type your question on the you can type the question. We have the can type the message here. 就是如果有问题的话，就是欢迎可以就是随时发问，我们也可以把问题写在留言区啊，那我们也看得到。中文，中文，对，中文，用中文或英文写都可以。
You can, everybody can write us in English or in Chinese. We can also translate for you. And if you have any question, you can say to us.
So maybe in the meantime, I can demonstrate what the manual is. I will share my screen. Here. So I told you there's a free manual for you within every experimentation kit, where again you have every part. You have a description of every part I showed you. You have a little theory in the beginning, and in the main section of the experiments. I will show you how our experiments are designed. So we have a little picture here picturing what is set onto the base plate. You have the requiring devices. Again, there is a little explanation here, and then we have a evaluation with some questions for the students. We have a teacher's manual with some sort of solutions, and we have a student's manual where solutions are not in there. And yes, so I have a manual. For instance, this is wind for students. Yes, a wind manual for students. Again, we have a pictogram here. We have a little chart here where the students can put in the results of their experiment. We have an execution set here, so we provide the student with every information needed, and the student then has to do the experiment by themselves. So please note that we are focused especially on the hardware. We think, or our company thinks, that the students has to experience these experiments by hand. Yeah, they need to take every module into their hands and have to see how it works, how it generally works, and also time. They need to investigate it by themselves. No digital course or something where they just start clicking onto the next task and everything. No, they need to do it by hand. They need to experience the whole new energy experiment by themselves. This is like company philosophy for us. Okay.
Okay, is someone else have some? Okay, I think have a teacher, professor have asked a question. Okay,
Yeah,
let's
they
see.
can be tested in a parallel and in a series connection. You can interchange this. I have here again show you on the bottom of the base plate are the conductive lines, and it's possible to just interchange it by turning it 90 degrees. This is the plug and play. Just interchange them, and now they are in a parallel connection, and I can close the electrical circuit on the bottom connections, and that's it. This is plug and play with all our experimentation kits. Yeah. Is it good? I always do this, and it still works. Okay, so yeah, it's quite durable. Generally speaking, we have some modules, especially with the polyelectrolyte membrane. Okay, they need a bit more maintenance with a fuel cell, but I say 95% of our modules, you can drop them onto the floor. They can do everything with it, and they work. So we have companies with us or schools where we check like every 2 years or so. We check the experimentation kits for them, and yeah, there's rarely a mistake in the modules or everything. So yeah, of course, minor things like a scratch or so can happen, but generally it's very doable. And we also have a school which has a product from us from 10 years ago and still working, or 15 years. It's one of the first product lines where we had like a wooden experimentation kit. This was the first experimentation kit ever, and it's still working. So yeah.
Yeah. Okay, thank for Zhou Honglong's question and thank. So is someone else have some questions? Yeah, maybe I want to ask help teacher ask one question. We know that the PV and the hydrogen we divide the two different stage of the experiment. Like have one is ready to go and the other one is professional. And we want to know this first stage of the experiment is what is the main difference of the direction? is one suitable for high school and the other one is suitable for the university to learn, or the others direction different?
So yeah, generally it's the ready to go is more on the phenomenological side of the experiment, so it's more suitable for younger students, and the professional products are more direct calculation, and yeah, you have to have more knowledge to use these and to do the experiments beforehand. So with for example, with the PV ready to go, we start what is an to demonstrate what is a fuel cell, what is a fuel cell module, and with the PV professional, we don't bother with that question anymore. Yeah, everyone should know what is a PV junction, what is a photovoltaics module, how does it work, and then we just work with that and go on into the deeps of the technology. Of course, if you want, or if you have some more experienced students, you can use professional products later stage of the school. Yeah, it's possible. I've done that. Or if you have like in the university, you have like you want to give an overview about the different technologies, or so you can also work with the ready to go products. Or if you have like second classes in university, yeah, where some students from other subjects only need to know the basics, yeah, just take PV ready to go, yeah, to show them. So it always depends a bit on the students. Also, what I missed to say is, like, we calculate like 2 or 3 students per experimentation kit. Yeah, it is possible, of course, to give one student one experimentation kit, but then generally the experiments take a bit longer. So at first, the students need to play a bit around with our experimentation kit to get a feeling of the different experiments. So what you've seen, what I was doing now was really changing every experiment very quick. This is only because I know what I'm doing, because I know what I have to do. But in first-hand experiments, always that the students need some time to adjust to the method of teaching. Again, they need to do everything by hand. There is no one guiding them beside the manual. So it needs some time for them to get into the topic. And this is why we say, okay, 2 or 3 students. So the students can work together, and they should work together. Yeah, teamwork's very important thing. And then they can figure out things together.
Okay, thank you. Yeah, and another question. And
I have done classes with 3 students. Depends on on how big your room is. I have done experiments with like I don't know what was the maximum, was like 40 or 50 students. Of course, I had more experimentation kits then, yeah. Like 4 students per experimentation kit for me is like maximum. So every student has something to do. Like 2 or 3 is best. Maximum is 35. Of course, it works. Maybe consider that it takes even longer then for one experiment to work. You can again, depending on your situation, maybe you have a general electricity switch for the whole classroom, yeah. So you let every student or every group of students set up the experiment, then check the experiment, then turn on the electricity of the room, and then everyone's doing the experiment. So you have to, the teacher can check beforehand if everyone's set up the experiment right. But so this is my method doing it. So about but generally speaking, there's no number too big. For like 35, it is possible, of course. Or you can, if you have different, if you have like 10 experimentation kits, you set up 10 different experiments beforehand, and the students just hop from station to station. It's also possible. I've also done this. Yeah.
Okay, thanks for Ronald and thanks for Professor Joe. So, is someone else have questions? Yeah. Okay, I think our time is almost. So, if you have some question, maybe you can send the email to us, and we will answer you. Yeah, and we can thank again for today's engineer Ronald, and we can give a big hand to him. Yeah, thank you for him.
Thank you.
Yeah.
Yeah, and our
So, Casey, you're muted.
Our CEO just joined us. This is our CEO from leXsolar. Everybody maybe now can turn on your camera and so we can see you.
Hello, Paul. Yeah, good morning or good afternoon from Dresden. Sorry that I passed the meeting, but I'm sure you was in very good hands with Ronald and Casey. They will handle very well. Maybe just a short overview from which countries we have guests today. Of course, from Taiwan, from Vietnam, I saw some guests. And maybe it would be nice how Casey mentioned when everybody can open the cameras that we can make a short a screenshot of all of us and also give a nice post from this great event today. That will be nice of you, please. Show us your friendly and happy faces, please.
我们可以拍个照留个纪念，所以大家可以稍微把镜头打开一下。那我们就很难得有这个机会了，就是大家很多国家的人可以一起这样共享盛举，所以大家可以把镜头开启。
So that's
我们可以留，OK。
Okay. So great. So then I make a short picture. Just a moment. Slipping here. Okay. So great. Thank you very much. So I hope you enjoy the time with us and that we can see you soon. And of course, I hope also that we give you the right arguments to think about now very seriously to invest in leXsolar solutions for your institutes, that your students and your customers can learn much more about new energies. And so then hopefully we can welcome you soon in our customer list. Thank you.
Okay, thank you, Michaels, and thank you all.
Thank you. So I think that will be. You're welcome, Mrs. Vani. I think that will be all for today for our online workshop. If you have any question, you can contact your local supplier. You can also contact us. And thank you for your participation.